Welcome everyone to another burst session on computational fluency. This session is focusing on kindergarten to grade 5 mathematics, specifically looking at practice tasks to support the development of computational fluency. My name is Janice Nowakowski, and I'm the district teacher consultant in mathematics and numeracy for K-12 in the Richmond School District. So just again, as an overview and a reminder, what is computational fluency? Computation is the calculation of numbers using the operations, addition, subtraction, multiplication, and division. When students have computational fluency, they are able to compute with efficient, flexible, and accurate methods and strategies. So those are kind of keywords: efficient, accurate, and flexible, and that contributes to fluency. Where does computational fluency live in our British Columbia curriculum? It's one of the big ideas in mathematics. When you look across the 5 big ideas, it is the second one. And you can see here, development of computational fluency in grade 4 and multiplicative thinking requires analysis of patterns and relations in multiplication and division. So it's really about that understanding of number as well as the relationship between operations. If you look at the elaborations at your grade level, you'll have that meta big idea that computational fluency develops from a strong sense of number. Students need to understand, count, decompose, play with numbers before they can compute with them. And then some suggested questions to support inquiry around computational fluency, which again really looks at patterns and relationships between operations and numbers. We have a continuum of computational fluency in our curriculum. Addition and subtraction starts in grade 1 with the introduction of the concepts and processes, and continues to grade 5, where we're developing fluency over the grades with mental math strategies, practice, application of some of those understandings, processes, competencies, and skills. And then the continuum for multiplication and division begins in grade 3, where those concepts are introduced and then practiced and applied across the grades until grade 7, where extending fluency is expected. Again, a reminder that that language in these computational fluency continuums that you see in the curriculum at grade 3, 4, 5, and then 5, 6, 7, the language of emerging, developing, and extending came far before the proficiency scale that we're now using. So they're slightly different in terms of what is meant by them. So one of the most common questions I get around computational fluency is, how often should my students be practicing? How many questions should they do? What does practice look like? So that's really what this session is addressing. What is practice? So practice involves both the development of content knowledge and competencies. So the math knowledge, understanding multiplication, but also the competencies that go along with that, like estimation or visualization, or using mental math strategies. And there are lots of different types of practice, and I'm going to just share some of them. A reminder that practice doesn't have to be on paper. Math doesn't need to be written down or done by yourself to count as practice. Math practice can be oral, it can be done with materials and visual supports, and it can be done socially. Practice can take many different forms. A Canadian math educator, Mark Chubb, defines practice maybe a little bit different than as adults what we experienced when we went through school, that practice can involve more opportunities for students to make choices or decisions about what numbers are used, what strategies are deployed, and what representations are used. And Mark calls this dynamic practice. And he bases his work around the work of Dan Finkel, who's a mathematician from Seattle, who talks a lot about playing with mathematical ideas, and that math is all about play. And so what does that look like in mathematical practice, practicing mathematics? So rote practice, that sort of on the left side of the column there, may be familiar to many of you when you went to school, that idea of mastery and memorizing, following procedures, pencil and paper practice. The role of the student is quite passive, little thinking, reasoning, or decision-making is done. And we often use the terms of drill and repetition. And again, that can happen as a form of practice, but we know that it doesn't take students far enough in their understanding and their transfer of thinking and strategies as the mathematics gets more and more complex across the years. So Mark suggests that we want more dynamic practice where students are more active in the thinking, decision-making, and reasoning required during that practice. So yes, it is still about understanding, and knowing the facts and the procedures and the formula and algorithms, but it's also being able to apply those with understanding and understanding the relationship between numbers, between concepts and the procedures, and that they come to a solution and they say, oh, does that make sense? And it's not just like, well, that's what I got. It's like, how can I make sense? And I know that is an accurate or close to accurate solution for whatever question they were working on. And again, the process for dynamic practice is those more playful experiences, games, puzzles, and infusing choice as a feature. And we know that's really important for thinking about the diverse learners in our classrooms too. The practice doesn't have to look the same for all of our students. The number ranges might be different. Students might all be working on addition, but there's some choice in terms of the number range or how many questions they do, etc. So from cognitive science research, we also have these three terms that you might hear. And again, specific to mathematics: retrieval practice, spaced practice, and interleave practice. And I'm just going to do a really quick flyover of those. Again, if you're curious about them, there's lots of information online or books, maybe in your school's professional library, that looks at sort of that cognitive science around practice and learning. So retrieval practice actually doesn't mean memorization, and that's often a misconception. Retrieval practice actually means retrieving something from your brain. And there's a lot of research that supports that act in itself of like remembering something and bringing it to the front of your brain and talking about it helps you consolidate and solidify that learning a little bit more. So again, beginning a math lesson with, oh, when we were adding numbers yesterday, what strategies were we practicing? And then not telling them what the strategies are, asking the students to retrieve that and remember what they had been practicing and talk about, oh, well, we were focusing on doubling and halving when we were multiplying, two-digit numbers. And, here's an example of one of those types of questions. That is retrieval practice. Spaced practice is when we might introduce, addition of two-digit numbers in October of grade 2. And we do that for a couple of weeks, and we do lots of different experiences with that. And then we let it go, and we might go and do some geometry or some measurement, but then we come back to it in December and again in March, and then again in April and May and June, because that's a really foundational, important thing that students in grade 2 need to know. But we're spacing it with other learning so that our brains have time to percolate in between the learning. And again, that is drawing from cognitive science research that has told us that that's how children's brains learn math better, is that when we space the learning out over time. Similar but different is interleaved practice. And so this might be, Friday was often a review day for me when I was in the classroom, and I might put some, 4 or 5 questions up on the board. But if we've been practicing, for example, this week we've been focusing on, subtraction with 3-digit numbers and the different strategies for that. So I might have 2 or 3 questions about subtraction, but I might have some other questions as well that I've put up on the whiteboard for students to copy into their notebooks and to solve. And by interleaving other content, again, supports children's brains and how they learn. And so if you just do all subtraction questions, they're just going to do what they've been doing all week and not necessarily make connections to other areas of learning. But again, the research supports that the interleaving the practice with other math topics in between those questions supports the sticking of the learning with students. Another form of practice coming out of research, and again, these are just names for different ways of engaging with mathematics learning. This is based on research from the University of Wisconsin, quite recent research, and that idea of deliberate practice. I sometimes use the term intentional practice. It's focused, it's repetitive, and it's at the edge of students' learning. So it moves their learning forward right from where they are. So assessment is really important here, knowing where your students are so that you can move their learning forward from where they are. You can connect this to maybe how you've learned to play the piano, or learn a sport, or learn to play a new game like chess that has a lot of steps or skills or knowledge built into that you sort of build up to it. When I was learning piano, you first learn scales and you learn chords, and then, you learn to put those together and read the music in a short piece. And those are those incremental steps that are building up to the goal. And then that sort of continues. You've got these smaller pieces that you're playing, that you're learning skills and sort of the feel for music within that leads you to be able to play a more complex piece later. And again, that's connected to mathematics learning as well. My piano teacher gave me feedback at every lesson, and, I'm noticing that you're doing this next week, before you come back again this next week, I want you to practice this. And she would write that in my music notebook that I would take home and I would practice, and I would take that feedback and practice the things that she asked me to. So again, connections to mathematics learning. Deliberate practice, there's two types of deliberate practice. Slowed practice, which really takes, a student solving a question and really having them slow down and be mindful of each step or each strategy or step in that process. So there's that metacognition that's coming into play there. And again, we know when students think about their thinking, they are more likely to remember what they're doing. And then scaffolded practice is when we're, again, doing those smaller problems to build to more complex problems, or we build sub-concepts that lead to a bigger understanding of a larger concept. And again, with deliberate practice, it's built on goals that maybe the teacher or the students have set for themselves as areas that they need practice. And you set a goal around that and a plan for working towards that goal. So key components of deliberate practice are being mindful or metacognitive. Understanding of what you're doing is really important, and that you're building on prior knowledge that you have. So what does that look like in K-5? We've had burst sessions on math games that you can go back to for some examples. Same with instructional routines. And then really, what are some other types of practice questions that we can provide our students? There's open-ended questions and there's computational questions. So computational in the sense that there's always going to be an accurate or correct answer, but there's different ways that we can practice that. Excuse me. So again, going back to some of those math games we talked about, how could we make the play of math games more intentional and focused on practice? And sometimes it's the language we use and being more explicit around that. So today, thinking I'm in a grade 3-4 class and we're playing circles and stars. And that's that game on the upper right there, where you roll a dice and you draw the circles and stars for the groups of, and you write the equation. You're going to ask the students to maybe set goals, the numbers that they're working with. Maybe they're going to work with 12-sided dice or 20-sided dice, or some students are going to work with 6-sided dice. Maybe you're going to focus on a particular strategy like skip counting or combining numbers or counting on. Or they're going to focus on an operation. In this case, if they were playing circles and stars, they're focusing on multiplication, but have them set a goal for their gameplay. Again, they might focus on a particular strategy to practice. If they're playing a dice game with 10 frames, it might be, building 10 or making 10. If they're practicing multiplication or division, it might be on doubling or halving. Or decomposing by place value to multiply. So again, naming a particular strategy that you would like students to practice helps that practice be more, that math gameplay, that practice be more intentional and focused. You can also provide choices for how students might share their learning. Again, you can see some students are recording that on paper. They might also take a photograph and do an audio narration or an audio clip that they're adding to that if they have an e-portfolio, etc. You can also provide a time, like we're going to play this game for 10 minutes, or you're going to play 10 rounds of this game, for example, and it gives that more focus and intention that this is actually, we're practicing something here. Same with instructional routines. It's about the language that we use. Instructional routines are really about whole group practice in developing both content knowledge and competency development. And we can take what we're doing in that whole group practice, and then use that in small group or individual practice as well. So you can see, again, this was an example from our instructional routines session on number talks, and I have an example there, 8 times 243, and students shared the lots of different ways they did that. So students have been exposed to multiple strategies now. And you can see I've put a string of 4 questions up on the right-hand side. And that's for then students to choose from to practice. So they might choose 2 of them or 3 of them, or they might do all 4, or they might just jump to the 4th one and then create some of their own as well, having that choice to create their own. This is where you can guide students certain ways and helping them make choices for numbers or questions that are in their range of learning. Again, that's going to help move their learning forward. But again, providing that choice for students, and again, they could solve that on whiteboards or paper with materials, etc. You can see on the bottom right, those are splats that are used for small group practice. So you might do, this was in a K-1 class and a 1-2 class. We might do a splat as the opening. And then during centers or math workshop, splat is one of those choices that students can use to practice with a partner, and they create their own splats. And solve each other's. You can see some examples there, again, to make those instructional routines more focused on practice, choosing a number range, a specific strategy. When I'm working with a small group, although we might be doing splat, I might have chosen a particular curricular competency to assess. And I have my little checklist out with my, my learning goals. And I'm saying, we're, really going to focus on you explaining and justifying your solution today. And I'm listening for how they're doing that. And that's what I'm assessing in the small group. So again, another type of practice. When we think about practice questions, open-ended or computational kind of questions, we've got open-ended practice questions. These have been really popularized by Dr. Marion Small. So for example, if 8 is the answer, what could the question be? And you can use this across the grades. If 4 and 25 hundredths is the answer, what could the question be for adding and subtracting, multiplying and dividing decimals? If 3/4 is the answer, what could the question be? There could be a whole bunch of things around that. That could also be operations of fractions in grade 8. How many different ways can you make 3/4 or 8 or 345? You could have a choice of numbers that the students could choose from. These could be out on tables. One table could have how many different ways can you make 25? How many different ways can you make 89? If that's a grade 2 class. You have blank yellow, red, and blue marbles. How many each of yellow, red, and blue marbles could you have? So there's also that logical thinking that comes into that, and combinations. And, if you have 20 of these, what are the possibilities of all the different combinations? And have I found them all? So that's a way to nudge beyond 2 parts. Some other examples from Marion Small, using soft words. So you divide number A by number B. The answer is a little more than number B. What could the numbers have been? And again, once you have some of these kinds of questions in your repertoire, you can use them across all sorts of operations and types of numbers. I'll just leave some of those there for you to have a look at and think about, oh, I could use that with this, or I could use this with a particular group of students as well. Maybe these are sort of extension questions that you're going to give some students, or you're going to open your class with one of these questions on the board and have students working groups to solve some of these types of questions. But Dr. Marion Small has several books published with questions like this, but she also shares some of them on her website, which is one2affinity.ca. And then also computation practice questions. And these can take lots of different forms as well. Again, it doesn't have to be written down. You could use apps. There's a multiples one for math tappers, but this is the Find Sums app. And you can see it on the top right there, those 2 green screenshots. You can choose, composing numbers to 5 or to 10 or to 20, or you see on the right hand is 100 frame. And so you can also choose your scaffolds for students. So the first one actually shows the apples. It shows the visual. So I'm going to click on 7 and it shows me 7 apples. And so I have to find the other number that makes 10. So when I click on 3, 3 little green apples will show up and that makes 10. So then it provides another question for me and I choose one number and then I find the other number that makes 10. On the right, you see the numerical version where it's parts wholes. So I've chosen 59, and you can see that the total needs to be 100. So I need to scan through those possibilities of numbers and think 59 plus what makes 100. And again, that is the Find Sums app, great for practicing that relationship between addition and subtraction in algebra. But Math Tappers also has a multiples app for that as well. So that connects multiplication and division. Those apps are all on self-service in our district, so available on our iPads. You can also use dice or cards to generate questions. This is just a photo example here. So this again might be during math workshop, and you say, create 10 questions, write them on your whiteboard. So, choose two numbers. I might choose a 3 and a 5. So I can either make 35 or 53. I put those down, and then I choose a dice. Again, I could choose a 6-sided dice, 12-sided dice, a 30-sided dice, building in that choice there for students so that they can think about what numbers do I need to practice and work with. They roll their dice, and then they either add on or multiply or divide or subtract, whatever it is that their goal is for their practicing on, to just they're generating their own questions. You don't need to photocopy anything. You set that up at the beginning of the year, and that can be a station or a center all year long. And then, of course, there's written questions. Depending on the grade level, you might do this once a week or once every 2 weeks, where you have a written record of some sort of students' computational fluency practice. So this one here that says grade 4 at the top, this is from one of the district assessment tools. We have questions like this for kindergarten through grade 7, where students have 4 questions that are grade level appropriate for the numbers and the operations. And students are asked to solve them in at least 2 different ways. So it's not just about getting the answer. They have space on the recording form to show at least 2 or 3 or more ways of solving that. And that's getting at flexibility with strategies. It's getting at accuracy. Do my answers line up? And it's also focusing on what proficient looks like in our curriculum. So just getting the answer and getting it only one way is not proficient. We have to have multiple strategies to solve computation questions. So this helps make that visible for students as well as for parents when we send that home. I Googled a practice math sheet just to sort of see what came up. And this was a grade 1 or grade 2 example. And this one isn't bad. It says addition facts worksheet, adding 8 and 9. So it's really focusing on that strategy of adding 8, something to 8 and something to 9. And again, I've put the little 10 frame of 8 up there as a visual support for students. I might have them do all the 8s first or all the 9s first if they're comfortable with 9s. Or I might have them circle ones that they think are going to be a little bit tricky for them, and they can come back to those. I might not give them that number of questions in one sitting. That would be a lot for a grade 1 or 2 student. I might cut this into 4 strips or have them fold it so they do 1 strip at a time. Do they need to do more than, 8 to 10 questions to practice? I don't think so. I think the more questions you do, the children that already know how to do these questions aren't getting any benefit from doing rows and rows of questions. And the children that are learning will feel very overwhelmed. And again, children that are really at the very beginning learning stage of this, maybe 3 questions is more than enough for them for their practice. So I think we need to be really flexible with this. And adapt some of these things that we might find online or from other sources, and be mindful of what our intentions are in terms of what students are practicing, and what strategies they're practicing and how many questions they need to do that. All right, so again, resources on the portal. Again, in the K-2 and the 3 to 5 Numeracy Foundations framework, there's a section on computational fluency, which provides you with, the key concepts, some materials and instructional ideas for you, some of those instructional strategies. And you can see right in the pedagogical design, it talks about opportunities for whole class, small group, and individual practice. So hopefully you've got some ideas today about what those different types of practice might look like. And again, for assessing computational fluency, all those computational fluency questions are available on the portal as well. And you can use the same questions all year long, 3 or 4 times over the year, to track students' progress, because it's not just about getting the answer. Again, it's about their fluency with describing the different strategies for getting to a solution. So as we come to a close, I'd like you to think about what different types of practice do you provide to support the development of computational fluency? How might you help students set their own goals so that their practice is deliberate and intentional and focused? What types of feedback might you provide while students are engaged in practice tasks? Because we know direct feedback in the moment at the time has the highest impact on student learning across all areas of learning, but in math especially. Thank you for joining me.